So, continuing with polishing our project, in this video we're going to fix a little bit the combat system, or just a part of it. Okay, and the part we're going to touch up is when we are looking to fire towards an enemy. Previously we were doing a raycast towards the target, and if we find a collider, then that meant that there is an obstacle in front of us. Now, the problem with that is that we have took care of all the colliders and we only kept some box colliders that indicate where a floor is. Okay, so we cannot use the collider that way. So we have to do something else. So we cannot use an actual raycast. We're going to do something like a raycast, but let's call it a nodecast, just for better phrasing. Since what we are doing is we are going to be drawing a ray from our position to the enemy's position, and we are going to be checking all the nodes in between, what do they have. So if there is an obstacle like this, okay, then you will see that we will start getting penalties. Now I'm going the way XCOM is, or the newer XCOM is. So even if it's a wall in front of us, or towards the direction of the enemy, we can still shoot, but we get a great amount of penalties that we are, a bigger amount of penalty of our chances to hit. And that is because, of course, there are distractible walls. We can have distractible walls too, and we will probably add them a bit later, though, after we have finished touching up and polishing our project. Okay, and the other case we can see is, of course, we have doors and windows like this. Okay, if it's straight from the wall, we cannot shoot. If we go, or we have a bigger penalty. If we have a wall or a window, we can shoot, but we have a lower penalty. Same for the other guys, you can see, and of course the closer we get, the better our chances are. So let's see how much work something like this simple thing we'll have to do. Let's go into our player interactions script, which is this one, and go to basically on the visualize combat. Oops. Okay, let me remove this. Now, a little bit of restructure we did. We still kept if we want to visualize the attack, if enemy target is not null, and if the active unit is not null. And I've added a new variable which I call previous enemy. So if the previous enemy is not the same as our own enemy target, we do this because we only want this to run one time when we are over our enemy. Okay, there's no need to calculate all this every frame, especially if our mouse didn't change a node position. So previous enemy is not the enemy target. We still find the start position and the end position. We still find all this, since we use this for the visualization too. We still need the direction. We normalize the direction. We get the node from the node position from the grid, and then we start adding a combat event. And I think the direction, we do not even use this. Let's see. Yeah, I see no errors, so we don't use this. Okay, we start a combat event. Previously we were doing a raycast, and if we were adding a combat event only if we have seen the enemy, or if the raycast didn't find any obstacles. Okay, we don't want any raycast now, we only use this. So combat event combat master. Okay, create combat event. We pass our active unit states and the enemy target states, and we assign our current combat event. We change combat text, all this stays the same. Previous enemy will be the enemy target. Combat line, we're placing the line on the start and the end position, and we also change the combat line, and I use find distance of type. Now I change this, the find distance of type. Basically it's not anymore distance based, it's based on the chances to hit. So yeah, whenever you see this, I will going to mean the chances to hit and not the distance anymore. So we start with being close, since so distance or chance to hit are good chances, and if our chances are greater than 85%, then that means we can have it at the green. If it's lower, then we start with medium. If it's lower than 40, then we go to the far color, and if it's lower than 15, we go to the black, so basically the out of range, and we return the distance type, so that in turns changes our line accordingly. Okay, these are the changes we have to do on the player interactions primarily, and of course on the else statement of the visualize attack and all this, we also need to make null our previous enemy, so the next time we go over this enemy, okay, then we can run and add the combat event once more. Now we need to go into the combat master. When we're creating a combat event, if you remember, okay, we close all the text. We have a new function we're going to see, which returns the node list. I want to save all the nodes we're going to look through with this function, which we're going to see, because as I said, later on we want to have destructible environments, so we need to save this. Now let's see this. Okay, of course to add a list to a return variable, we have to go into a class and add a public list of nodes. Okay, add the namespace too and all that. So what we're going to do first of all is find the nodes we're going to look to, and this function will take the unit states of the attacker and the defender. So return value, we add currently the node we are in, and that is kind of important. Okay, and we find the origin and the target. Of course our origin will be the attacker's transfer position and the target will be the defender's transfer position. We find the direction, which is target subtracted from the origin. We normalize it, of course, and then we make a new ray from the origin towards that direction. A ray is a straight line that never ends. Okay, so we need to know the distance between target and origin, and then we can have our samples. So we round to int this distance, and we're basically taking based on the distance we have, we are going to sample positions and take the nodes from those sample positions. So if I am over here, okay, it's going to take all the nodes that are in between the attacker and the defender, and it's going to check what they have. So in this case it will see that there is a wall at this point, so it will add a penalty. Okay, let's go. Now this way we can add even more samples though. So even if we are shooting this guy over here, if we missed, we can make checks and hit something that is beyond him, so hit something else after we have find this guy. So yeah, there's a lot of power this way we're doing it. Of course, there's some also tricks. So we do a for loop for each sample we have over here. Now keep in mind that if the distance is, even if the distance is 1, we're going to basically sample if the attacker was over here and the defender was over here, the distance from here to here it's higher than 1, so that means it's going to still hit him. So we find the node position from the get point from the array, and we pass the current sample. We find an instance of the node, and if we haven't yet added this node into the return value, then we are adding it. Okay, we need to add this to do this, just because we might have duplicates into our node, and we do not want any duplicates. So we do not want to checking a node 2 times before we add the penalty. After that, we remove the attacker, or the attacking node, since if we are at a node like this, okay, we do not want any penalties because we are into a window. Okay, there's no need for that. So we remove that. So after that, of course, we need to make sure the defender node is inside the return value, so we add him at the end. Of course, we can we should probably do this, and it will only add him if he's not already in. Now we have all the nodes we need to check. We have our chances to hit, the way we were doing this before, but before we were using this the return of this function directly on the chance to hit. Now we're going to do something else, so we're going to store it first. Our base chance to hit based on all the modifiers we have set up in here. Okay, I haven't changed anything over here. And then we're going to find an obstacle penalty. So this is the new function we're going to write. It's going to take the list of the nodes we want to check, and of course the unit states of the attacker and the defender. So obstacle penalties, return value will be 0. We need to find the direction, and of course we do that. Well, we need to find just one direction, basically, just the node that is closer to, or basically the next node into our graph, into our list. Okay, and because we can only move straight, okay, there's no need to go and find the end node. Okay, so we just use the node, the second node we have into the node list, or yeah, we can use the first one, I guess, since we removed the attacker's current node. This will work too, probably. Okay, we find the direction, we just turn it into a vector 3. So instead of writing new vector 3 and passing the diff x, diff y and z, okay, this just creates a little less garbage. So for each node we have into our node list, we store the node, we check if the direction is not two-dimensional, so if somebody is on an above or below node, we handle things a little bit different. So before we see this, let's see if they are on the same floor. So if they are on the same floor, if the current node we are looking to is walkable, then that means there's no obstacle in the way. So the only thing left to do is check if there are walls inside the node. So we create a new float which is going to say direction penalty, and we're going to use this function check direction, and we need to pass the different x, different y, and different z, and the node. And I think, yeah, this might be redundant. Anyway, we will see. Okay, so this function, what it does, it takes the node, of course, starts with a return value of 0, and it checks if the different x is not equal to 0. If it's 0, that means we are not moving on the x. The direction we're going is not, it's not the direction. We might move straight to the north or straight to the south. Okay. So, if we are moving on the x, then we need to check two cases for each node. So we need to check the first wall and the second wall, since a node might have even more two nodes. And yeah, I get the error. Okay, since a node might have walls from all four sides, we basically need to check every time all the four sides of a node. So if we are moving on the x, then we find the path direction for the east and for the west using return direction, and we are called with the enum. We find the penalty from another function, which we call return penalty from direction, and once we have our penalties, we add both of them to the return value. So this can return 0, so the return value plus 0 is still the same return value. Okay, let's see this one. Return penalty from direction status. Okay, you pass the status and you say if it's walkable, then add nothing. If it's partial, then add the return value of 5, and if it's blocked, add the return value of 15. Now keep in mind that at this point there is a big chance that we are looking at a duplicate wall. So if we are looking on the wall of this node, of this wall over here, when we are looking this node, then we might still look this node, this wall. Okay, so it might add a penalty because this node is going to also check that there is a wall over here. Now there are other ways to handle this, but the simplest way is to just add just subdivide the value you want to pass, the penalty, just subdivide it by 2. So if there's a wall, then this will be instead of 5, it will be 10. Okay, because we check two nodes together. Okay, and then if the direction status is blocked, then that means it's a whole wall between us. Then just add 15, so that will be 30, or you can go even higher. Then we check, and on the z direction the same thing. I have to name this north since the n is the node. Okay, and then we return the penalties, so we add that into our return value. Now if the node is not walkable, then we need to check if the node type is not air, and if the node is not the defender's current node. So because the last node on the list is going to be the enemy, and that node is not also walkable, since there is an enemy in there. Okay, then we check if it's not that, then that means there's nothing on the node. Of course there might be walls, so we need to do exactly the same, and you can say that there is also an obstacle there, so we add plus 30 and plus any penalty it might have on the node, okay, or from the direction, from the walls and all that. Okay, and that's how we add the penalty on 2 dimensions. Now on 3 dimensions, we check if the current node we are looking to is not there, that means it's ground, of course, and of course if it's not, the defender's current node. Then the return value will be a greater penalty. We'll start with plus 50, because that means we are actually shooting through the floor, and then we can have our direction penalty, same with check direction, so the penalty for the walls basically. Okay, and we return that as our penalty from the obstacles. We take that and we subtract it from the chances to hit. So if this returns 100 and this returns 50, then our chances to hit will be 50. Of course you can add some more multiplications over here, but I'm going to leave that entirely up to you. A few checks we can do just to ensure some better gameplay, I guess. If our chances to hit is lower than 0, then make them 0. If our chances to hit are greater than 100, then make them 99. And then we pass to the return value the variables we want to pass, and then we return our combat event. And everything else will be handled as it was before. Okay. So, with that, I think we are, I've covered everything I think I want to cover. So, this will work even from any floor we want to go up. Okay, of course this is very far away, and you can see that the distance returns as minus 11%. That if these guys get closer, okay, we get better distance and we get all the other stuff we have talked in the past. So, and on the next videos we're going to focus on keep polishing this, so that's why these are shorter, because we have a lot of stuff and they are not particularly connected with each other. So we still have to work with making the animations not look that bad and making him play the correct animations, and we still have to do a few more other things that we're going to see. So I'll end the video now. You know what to do: like, subscribe, Patreon, Gumroad and all that, and I'll see you next time.